Hi everybody. In this video I'm going to talk about just an overall review of basic introductory algebra 1 topics ranging from basic topics involving integer combinations like adding, subtracting, multiplying, dividing, all the way up to order of operations, substitution, and evaluation, and then finally we're going to look at one scenario involving a word scenario. Okay, so let's go ahead and jump right in. I'm going to do select questions from here. So I'm going to begin with number 1. Now, when you're looking at something like number 1, you want to think of a number line. So if you're starting at -4 and then from -4, so let me draw a number line for you here. So if we're starting at -4, right? 0 might be somewhere over there. This plus -4 you see on the right side, right here and there, what that means is that from your -4, which is your starting position, so from -4, you're going more negative. So that's what this means, that you're going more negative from -4. And that can only mean that you're going in the negative direction. So if I were to jump 1, 2, 3, 4 in the negative direction, then where would I stop? Well, if this is -4, then this would be -5 and -6, -7 and -8. And so -8 becomes the answer. Now, this is a rather detailed way of it, and long about way of getting the answer. A more sort of conceptual way and direct way of doing it would be to understand that by going more negative, you're actually adding these numbers together. Okay, so -4 plus -4 becomes a -8. I'm going to go ahead and erase all this. And the answer is -8. All right. Number 2, right over here, 5 times -7. When you multiply or when you divide, one method is to remember this face here. Now, the way this works is you can only multiply two numbers at a time, or practically speaking. So when you have 5 and -7 and you're multiplying them together, what you want to do is you want to hide the signs that belong to each value. So since my 5 is positive, I'm going to cover the plus sign or the mouth. And because my 7 is negative, I'm going to cover one of the eyes. And that leaves only one more eye, which is a negative, and that means that my result will be a negative number, and then 5 times 7 is 35, so the answer is -35. Okay, moving on. Number 3, same idea, and we would get -10. Okay, number 4, you do everything inside. This is a question involving the order of operations, or the order in which numbers should be combined according to their operations, or add, subtract, multiply, divide. So when you have parentheses, that's a group of numbers inside that have to be combined into one single value. And I have both multiplication and addition, which means I need to decide which one should happen first. And if you follow the list, which is here, I like to organize it this way. So multiplication and division are in the same family, which is why I paired them up this way. And addition and subtraction are in the same family, which is why they're paired up that way. When you go top to bottom, you see that the first thing you have to do, the very first thing is actually whatever's in parentheses. So that means that I need to combine everything inside first. And between multiplication and addition, because multiplication is higher on the list than addition, right? Multiplication is right there. This has to be done first. So 6 times 2 would be 12. So this is 4 on the outside. Then you have 12 plus 3. And now multiplication is done, or at least for the inside. And so I have to now add 12 plus 3. 12 plus 3 is 15. So now I have 4 times 15. And the last step is to actually go ahead and multiply 4 and 15, and the answer would be 60. Okay, that's number 4. Number 5, the first thing I have to do is replace the variable with their assigned value. So in other words, wherever I see a letter B, I'm going to assign that variable a number 5. And wherever I see a letter C, I'm going to assign that a number 1. So that means that this will become 5 multiplied by 6 plus 1. And just like I said before, with order of operations, you have to do whatever is in parentheses. So this now becomes 5 multiplied by 7, which then becomes 35, and that would be the answer. Number 6, this is a question involving distribution, the distributive property. The distributive property uses a value outside to multiply with all the terms on the inside. And you have to be careful to be mindful of the value, the sign of the value outside. So in this case, we have a 10 multiplying with a -5. So 10 times -5. And we also have a 10 that's multiplying with a positive 1n. So 10 times n. Now 10 times -5, if you think about the face once again, you would cover an eye, you would cover a mouth. This would be -50. And 10 times n is simply 10n. I can write that without the parentheses. And this is the end. You cannot combine these two values together, these two terms. Those cannot be combined because they are not like terms. The -50 does not have an n, and for that reason alone, they should be left separate. So -50 plus 10n is the answer. Number 7. So this question involves a combination of like terms. So to identify like terms, you have to look for terms that have the same variable and the same exponent, and the exponent has to be in the same place. So that also, the other qualifier for like terms is numbers that have no variable. They also can be put together by addition and subtraction. So combining like terms is only ever about adding or subtracting, not about multiplying and dividing. So if I look over here, I can see right away that I have a -10, which does not have a variable, and I have a +1, which also does not have a variable. And that means that these two will combine together. And when I do so, I get -9, okay? It's like being at -10 and taking one step in the positive direction. You're still going to be in the negative, but you're going to be a little closer to where the 0 is by one step, and now you're at -9. Now, the other like terms would be this 3b you see here and the -3b. And I want you to note that I enclosed the sign with the 3 and the b, because it's important to know how you're supposed to combine these. So if I have a 3b and then I have a -3b, that simply is like saying what's 3 minus 3? And we know the answer is 0. So in other words, these two cancel each other out and make a 0, and that leaves just the 9 as my answer. Number 8. A great sort of temptation for people to do is to look at that 9 plus 7 and think, oh, 9 plus 7 is 16. Easy. But you don't want to jump right in and add those. And the reason is because this 7 that you see over here, this +7, is actually multiplying with the group, the -n minus 5. And because it's multiplying, and you think about the order of operations, and I'm going to put that again over here. All right, so we go top to bottom. When you look carefully at this list, it dictates the order that you have to take with these things. So we have multiplication right here. Multiplication happens before addition, which is last, all the way at the bottom of this this ladder. And so we have to multiply this -7 inside, or distribute it inside, before we do anything with that 9. And so what we get is the 9 comes down, and 7 times -n, this is actually -1n. 7 times -1n is simply -7n. And then 7 times -5 is -35. Just referencing the face again, you would cover a mouth and you would cover an eye. Okay, so -35. And then I need to step back and think, well, do I have any terms that could be combined? And it looks like I do. So I have a 9 here, and I have a -35 here, both of which lack a variable. And the key variable here would be an n. So because they don't have a variable, that qualifies them as like terms, and I can go ahead and combine them. So 9 minus 35 would be negative 26. And then I bring down the negative 7n, and that would be the end. Now there is another way to write this. So the other way would be to reverse the positions of my terms, and I could put negative 7n first, and I have to be careful that this negative follows a 7 wherever it goes, because it is a negative 7n. And the minus 26, or the negative 26, same thing, goes at the very end. Okay, so two ways that the answer could look. All right. So that is those are level 2 type questions, or in other words, these are C level questions, skill questions for Algebra 1, introductory level stuff. I do want to jump down. The Mastery Level 3 material is very much the same in terms of what you have to do. I do want to jump down to level 4 and look at 2 questions only. Those would be actually 3 questions. Those would be 17, 19, and number 20. Okay, so we're going to start with number 17 over here. What you want to do is you want to first recognize that, hey, I have a double negative here. Now, a couple ways to understand this is that this is actually saying or asking, what is the opposite of a negative? Okay, what is the opposite of a negative? So if I were to ask you, what's the opposite of off, you would say on. The opposite of left, you would say right. The opposite of a negative, hopefully you would say positive. And so that's what we have to do with this. We have to take the opposite of a negative 3 and turn it into a plus 3 or a positive 3. And then I scan everything else to see if there's anywhere else I need to do that, and there is nowhere else to do that. So I go ahead and rewrite everything. So this is now negative 7 plus 3 minus 2. And then this plus negative 2, you could either leave it like that, which is like saying whatever you have on the left side, you're then going to go more negative by 2 steps. Or you could simply write this as minus 2, and it's up to you. I'm going to write this as minus 2, okay? Now, I only have adding and subtracting here, and according to the order of operations, if you remember, and once again, I'm going to write this down. Order of operations, at this line, you have adding and subtracting. These two are in the same family with each other, which means if you have nothing else from the list, then you simply go left to right, and you handle 2 numbers at a time. So I'm going to put these together first. Negative 7 plus 3, that becomes a negative 4. So this is negative 4. And then I have minus 2, minus 2. Okay. Going left to right again, I'm going to put together negative 4 minus 2, and I'm going to swing this way. Negative 4 minus 2 would be negative 6. And now I have negative 6 minus 2, which is the last 2 in this long string of terms. And then finally, negative 6 minus 2 would be negative 8. And that would be the end. Okay? All right, number 19. In number 19, first thing you want to do is distribute anywhere you can. And looks like I can distribute this negative 6 inside. And over here, there's a minus sign, and it appears like there are no numbers here, but there's a negative 1. So I'm going to distribute a negative 1 inside. So doing this carefully, negative 6 times 1 is negative 6. Negative 6 times 9x is negative 54x. Negative 1 times 1 is negative 1. And negative 1 times negative 2x is positive 2x. Okay, so I need to look for like terms. Okay, always after distributing, see if you can spot the like terms. And if you do, put them together. So it looks like my like terms are negative 6, negative 1, and negative 54x, and positive 2x. So I'm going to link these together, and I'm going to link the orange ones together. And I'll do the orange ones first. So negative 6 minus 1 that will be negative 7. So negative 7. Negative 54x, these are now the green ones. So negative 54x plus 2x would be negative 52x. And that is the end. And once again, you can rewrite this as, if you want to, you could put the x term first and write negative 52x and then minus 7, okay? All right, last question over here is the word scenario. I personally like word scenarios because it really does give a sense of how to apply these skill-based concepts. So the 9th grade council is raising money for homecoming. Right away, this is something that once you read all this, you don't need it anymore. It doesn't add any information to the math other than creating a story in your mind, okay? So we got it. So 9th grade council is raising money for homecoming. They're going to pay the DJ $25 per hour. Okay, so now we're getting to information that we could potentially use. So $25 per hour. There's a word plus here, which is extremely important because we're going to translate that. Plus a $100 setup fee. Okay. And I'm going to read on. So they plan to have security for $15 per hour. So I underlined that part. Notice that I skipped something between the word fee, which is over here, and the number 15. And the reason I skipped all this over here is because it is part of the once you read it, you don't need it words. So we know security is going to be $15 per hour, but all we need is that 15 per hour. Now, I saw the words per hour over here as well. Okay, so we see it twice. That means that the total for this event will depend on how many hours it actually takes place. So it's time measured in hours, which drives the cost of this entire event. Okay, so letter A, write an expression for the total cost of the fundraiser. So this is our task. We're going to write an expression for the total cost. Okay, for the total cost. So I need to have a variable that represents what drives the cost, which is hours. So I'm going to say that my variable for this will be the letter H. So H represents number of hours. Okay, and then I'm going to use that to create my expression representing the total cost. So I'm going to begin with $25 per hour for a DJ. So it's going to be 25 per hour. To show that, you multiply 25 by H. Okay, then here we have this word plus. Now that's really helpful because we just do a direct translation into a plus sign. And then we move on, plus $100 setup fee. Now a setup fee of $100 is something you pay one time, and then it's not paid again. Unless you have to do this event on a separate occasion, then you have to pay $100 again. But it's a one-time fee. Then on top of this, we have $15 per hour for security. So I need to show that by writing $15 times H, okay? Because it goes by hour. So that this is our expression for the total cost of this event. And then in part B, it says simplify your expression, which means I now need to look for my like terms. So my like terms are, wrong color here. My like terms are 25H and 15H. So being positive values, I simply add them up. And what I get from that would be 40 times H and then plus the $100 setup fee. Last part is use your expression to find the total cost for 5 hours. Now, so I'm going to use the expression, okay, to find the total cost for 5 hours. So this 5 hours that we see, this is key because now I have an actual value for H that I can use to plug in to my expression. And so I'm going to do this. It's going to look like this. So I have 40 times 5 plus 100. $40 times 5 hours would be a total of $200 for that, plus the cost of the, the cost of the setup fee, which is $100. And then the total comes out to, the grand total is for 5 hours, you would expect to pay $300 total is paid for 5 hours. Okay, for 5 hours, and this connects with everything else. And so there you have it, folks. A general overall review of basic algebra concepts involving integers and application. I hope this helped. As always, stop by, leave a comment, and thanks for watching. See you next time.